Welcome back to Makerium. In this video, a bold new creation begins to reveal its story, a unique craft inspired by the sleek lines and daring design of the SU35. What begins as admiration for a supersonic fighter evolves into a vision entirely its own. A craft designed not to move gracefully across and beneath the water, blending ambition with innovation in a way that has never been attempted before. The construction of the watercraft begins with the skeleton, which forms the very foundation of the entire project. Sheets of Fomex plastic are selected for their combination of flexibility and strength, providing a lightweight yet durable material suitable for shaping a composite structure. The sheets are aligned and fastened to create the exact inverse of the final watercraft shape. Every curve, edge, and panel is carefully positioned to ensure that the negative mold will produce a perfectly symmetrical and smooth composite shell. This stage is a delicate balance of precision and patience. The skeleton acts as the blueprint for the watercraft's outer form, capturing both the aerodynamic elegance of the SU35 and the functional requirements of a lightweight hull. Each element of the skeleton is measured and cut to precise dimensions, then positioned within the negative mold. The alignment is checked repeatedly, making sure that all the forms follow the contours of the mold exactly. The use of plastic boards to create the skeleton for a positive pattern or plug is a highly efficient and common method in composite fabrication. This technique provides a quick way to establish the complex, three-dimensional geometry of the final product with high accuracy before the molding works. The internal skeleton's primary function is to provide a rigid, lightweight armature that ultimately defines the plug's shape and structural integrity. This essential framework sets the symmetry and strict adherence to the original SU35 design specifications. The skeleton serves a vital support role, acting as a structural base capable of holding the heavy layers of putty, fairing compounds, and smoothing materials that are applied later in the finishing process. Or the builder. Using plastic boards enhances efficiency as it allows for the rapid cutting and assembly of cross-sections and stringers of the design, effectively repeating the internal lattice structure of an actual aircraft. The creator's primary challenge is recreating the aircraft's aerodynamic shape and adapting it to a hydrodynamic vessel. A deep understanding of the original aircraft is needed as the structure is made to imitate the SU35. The aircraft is a highly advanced, single-seat, twin-engine, super-maneuverable, multi-role fighter developed by Russia and is considered a 4++ generation platform. Its design is characterized by enhancements in aerodynamics, power, avionics, and structural integrity. The wings are reinforced, and the tails and vertical stabilizers are enlarged, improving stability and control. The blending of the wing and fuselage, known as aerodynamic coupling, is refined, allowing the fuselage to generate significant lift. The SU35's key feature is its unmatched maneuverability, which comes from its advanced propulsion system. Because of this, the twin-engine design is essential for the watercraft to look true to the fighter. If you are following along and enjoying the build, please like the video and subscribe. It's the most effective way to support our work. The aircraft's 3D thrust vectoring control, which lets it direct thrust in 3 dimensions for extreme moves, cannot be replicated in water. However, the twin-nozzle engine bay is carefully shaped by the plastic structure to maintain the fighter's aggressive appearance. The SU35's design depends heavily on its wide, flat central fuselage. This broad, blended shape is not just for looks, it is essential for generating aerodynamic lift on the aircraft. For the watercraft, this wide, flat lower surface is preserved, but it serves a different purpose. It provides a large planing surface that allows the vessel to glide efficiently across the water at high speed. The builder must carefully maintain the angles and sweep of the wing roots so that the fuselage transitions smoothly from the nose to the rear. This ensures both the visual accuracy of the SU35 and the functional performance of a high-speed planing watercraft. With the framework and forward section completed, the next stage focuses on building the hull itself. Sheets of Fomex plastic are assembled, transforming the skeletal plug into a solid, continuous form. The careful installation of the nose cone completes the assembly process, turning the skeletal framework and plastic boards into a fully formed hull. With the main structure finished, the craft is now ready for the next phase. To achieve a smooth, seamless finish and prepare the hull for composite layers and final coatings, putty is applied. The process starts with the joints and screw holes, where small gaps and imperfections are most noticeable. Multiple layers of putty are applied to the entire hull. Once cured, the surface is sanded to remove excess material, ensuring that the hull's contours and curves remain precise. A water-based non-stick agent is applied to the surface to prevent the composite layers from adhering to the mold. This allows the resin and fiberglass layers to be applied cleanly and later removed if necessary. A durable, scratch-resistant gel coat forms the inner surface of the mold. A specialized tooling gel coat is applied in several layers and left to cure until it becomes firm, but still slightly tacky before the next step begins. Layers of fiberglass and resin create the structural strength and thickness of the mold. While the gel coat is still tacky, the first layer of fiberglass mat is applied and saturated with resin, with rollers used to remove any air bubbles. Silicone-coated fiberglass fabric is applied, forming one of the structural layers of the composite hull. This material is chosen because it releases cleanly from the mold while still providing a stable base for the additional fiberglass and resin layers. With one side of the mold completed, the process continues on the opposite surface of the hull, following the same methodical sequence to ensure perfect structural consistency. The newly exposed side is treated with a water-based non-stick agent applied evenly across the entire surface. This coating ensures that the next composite layers will release cleanly once cured, protecting both the mold and the finished hull. Once the non-stick agent has dried, the surface is sanded to achieve a smooth, uniform finish. During this stage, water helps cool the material, as sanding generates heat through friction. Wet sanding also reduces dust and keeps the surface clean. While the gel coat is still slightly tacky, fiberglass mat is positioned over it. The light adhesiveness of the gel coat helps the fabric settle naturally into every contour. After the silicone-coated fiberglass and subsequent composite layers have fully cured, the structure is ready to be separated from its temporary internal framework. The cured fiberglass shell, now rigid, stable, and holding its precise aerodynamic form, is lifted away from the inner support structure built earlier from plastic boards. This creates the negative mold, which is now ready for further work. The gray gel coat is brushed onto the negative mold, ensuring even coverage over every curve and edge. This layer is crucial, as it forms the final outer surface of the watercraft, providing both durability and a polished finish. Once applied, yet slightly tacky state, preparing it for the next stages of fiberglass lamination. In addition to its aesthetic role, the gel coat also serves a protective function, shielding the hull from water, UV exposure, and wear over time. Steel components are installed at critical points where mechanical loads are concentrated, such as engine mounts, propeller housings, and attachment areas for internal frameworks. A bonding agent is carefully applied to secure each insert, ensuring a strong, immovable connection. Any excess material along the front nose cone mold is trimmed, and the two sections are aligned and secured with screws. This creates a stable assembly that serves as the foundation for constructing the front part of the watercraft body. A gray gel coat is applied to the negative mold of the nose cone. A layer of fiberglass mat is then placed over it and fully saturated with resin, forming the first strong and rigid layer of the front part. The tail fins, serving as the vertical stabilizers in the SU35 inspired design, are built using the same complicated process. Every step, from mold preparation to the construction of the main body, is carefully followed to ensure both structural integrity and visual accuracy of the watercraft. Instead of using new components, the project takes a sustainable approach by restoring two old propellers for the watercraft. Each propeller is disassembled, giving access to all internal parts for thorough cleaning and repair. All components are cleaned, sanded, and polished, restoring smooth operation. These units create thrust. Water enters through an intake, is pushed forward by a spinning impeller inside the housing, and then shoots out, as a high-speed jet through a steerable nozzle at the back of the vessel. Two old 650cc Kawasaki engines are positioned within the reinforced mounting points built earlier into the hull. Originally designed for personal watercraft, these engines are known for their reliability, compact size, and strong power output. The exhaust system is integrated for efficient engine performance and safe operation. It directs combustion gases away from the engines while helping control temperature, reduce noise, and maintain the proper back pressure for good power output. Once all adjustments are made, the upper section of the vessel reaches its point of completion within the negative mold, a fully formed composite shell that is structurally sound, cleanly contoured, and ready for the next stages of assembly. Thanks to the earlier applications of water-based and wax-type non-stick agents, the release process is smooth and controlled, allowing the hull to detach without damage. The next step focuses on preparing the vessel for upcoming mechanical and design additions. Two cutouts are made in the rear section of the hull, marking the start of the customization phase that will house essential components and future upgrades. Precise holes are drilled into the body to serve as attachment points for the removable wing system. Their locations are chosen to ensure proper balance, symmetry, and structural support. The wings undergo the same process, with matching holes drilled to the same diameter. Pipes are inserted through the openings to connect the parts securely, acting as strong, rigid supports that lock the wings in place while still allowing for easy removal when needed. A section of the wing is trimmed and shaped to form the movable surface called the elevator. This essential aerodynamic component allows precise control over the craft's pitch, which is the nose-up or nose-down rotation around its lateral axis. The main section of each wing is coated with gel coat and sanded to remove any minor imperfections. The joint between the wing and the body is filled, creating a continuous surface that improves aerodynamic efficiency by reducing turbulence. The next stage involves installing the rear wings, which function as stabilizers. The process closely follows the steps used for the side wings, but they are designed to be movable, giving the craft additional maneuverability and more precise control. To achieve this functionality, the internal structure of each rear wing is reinforced with additional support pipes. These pipes act as pivot shafts, allowing the wings to rotate smoothly while withstanding water pressure and dynamic load forces. With this step completed, the craft gains a fully functional set of rear stabilizers, and the next stage involves installing the tail fins, which serve as the vertical stabilizers of the watercraft. To preserve the authentic silhouette of the aircraft, small external components are added to the fins, representing the radar warning receivers. The next phase involves creating the mold for the watercraft's canopy, the transparent dome that will provide the operator's enclosure and define the craft's cockpit profile. This process begins with constructing a precise skeleton mold to capture the distinctive curvature of the watercraft's canopy. Plastic boards are selected as the primary material for the skeleton. A layer of putty is then applied over the assembled plastic structure and sanded. By conforming the fiberglass fabric to the prepared skeleton, the desired profile of the canopy is created. The structural profiles, like thin strips, are cut and bonded onto the fiberglass shell. They are positioned exactly where the real SU35 canopy would feature its framing lines, acting as the distinct frame for the glass sections. The temporary mold profiles are removed, leaving behind a perfectly shaped indent on the canopy's surface. This indent is then refined, creating a recess of a precise depth. This newly created recess functions as the frame, providing the necessary space for the installation of the transparent acrylic sheet that will form the actual cockpit glass. Acrylic sheet is highly favored in genuine aircraft manufacturing as a lightweight replacement for glass. It possesses excellent optical clarity, ensuring the future operator will have an unobstructed view. The acrylic sheets are heated and shaped to precisely fit into the glazing channel. This ensures a seamless, aerodynamically clean integration with the fiberglass frame. The canopy shell is removed to be cleared from the molding skeleton that defined its shape. Demolding must be performed with great care to prevent damage to the delicate fiberglass frame. All the excess parts of the fiberglass are trimmed away. Also, cutouts are made in the areas corresponding to the glazing channels. Next, attention is focused on the fully functional landing gear. These assemblies are engineered to perform, allowing the watercraft to be rolled and maneuvered when out of the water. Every component, the struts, the axles, and the wheels, is designed to handle the load and facilitate movement. The front landing gear is built into a robust working unit. The main strut, which acts like a shock absorber, is mounted to manage the real vertical load and absorb any bumps. The axle is fitted with strong bearings, so the two front wheels can spin freely and easily. Once those wheels are on, they are ready to guide the whole craft across the ground. The next vital step in assembling the landing gear is ensuring smooth operation and longevity by adding lubricant to the strut mechanism. This minimizes friction, prevents wear, and ensures that the suspension operates freely. The rear landing gears are responsible for supporting most of the watercraft's weight. It is crucial that these twin assemblies are installed perfectly evenly, as any imbalance could compromise the vessel's stance. Unlike the front gear, the rear gears have trunnions and braces. Together, these components ensure that the main gears maintain their exact alignment and position, providing the structural stability necessary for the watercraft to be supported under its own weight. It's time to focus on the powerhouse of the watercraft, where the Kawasaki two-cylinder, two-stroke engines are prepared for their role. The engines are thoroughly washed to remove any residues and debris accumulated during previous operation. The carburetors, components vital for mixing air and fuel, are prepared and painted black, and the entire engine is coated with protective paint, giving it a factory-fresh appearance. Before assembling the jet drive pump components, the area where they will be installed is painted and prepared for fitting. These components include the main pump body and the steering nozzles, which direct the flow of water for steering and reversing. This system provides propulsion by drawing water into the pump and expelling it at high pressure through a nozzle. By forcing a mass of water backward at high velocity, it creates an equal and opposite reaction force that pushes the boat forward. To complete the electronic system required for maneuverability, the servo controller boards are prepared for installation to operate the high-torque servos that manage the crucial control surfaces. It functions as a dedicated power distributor, isolating the high current draw of the servos from the sensitive low current electronics of the main control system, thereby protecting the craft's vital components. The remote-controlled system is set up using the radio link transmitter and the R9 DS receiver, which are connected to a motor driver board for stable signal transmission. The receiver links to the motor driver board, which powers and controls the motor based on the wireless commands sent from the transmitter. This configuration is typical for projects requiring simple and reliable motor control. To create a rigid base for the steering actuator, a metal plate is used as the mounting platform for the high-torque servo. Several metal components are welded to this plate, forming the foundational structure and articulation points for the steering linkage. A metal arm and a wing nut assembly are securely mounted to the nozzle. The arm is then mechanically connected to the servo assembly, acting as the lever that receives motion from the servo system. When the servo moves, the linkage system transmits this force to the nozzle arm, pivoting it side to side to direct the water jet and provide steering control for the watercraft. The final mechanical integration involves connecting the renewed Kawasaki engine to the exhaust system, ensuring that waste gases are efficiently routed away from the engine. The next essential task is the construction and integration of the complete fuel delivery system to support the renewed engine. This process ensures a clean, reliable fuel supply without leaks. First, the fuel tank is assembled using tubes, reflecting a segmented design built to fit the unique contours of the hull. A fuel filter is then mounted along the line, ensuring that only clean fuel reaches the carburetors and protecting the engine's internal components. The entire fuel line is carefully routed and adjusted for proper operation. Ailerons are the wing components that control the aircraft's roll and lateral balance. In this project, they are attached using hinges, ensuring they can move freely up and down. The watercraft is now prepared for its defining aesthetic feature, the two-tone camouflage scheme involving a light blue and white, which replicates the iconic look of the real SU35 fighter jet. First, it is painted in light blue. Then, a pattern is applied using precision masking techniques to create sharp-edged designs across the fuselage, wings, and stabilizers, reproducing the hard transitions characteristic of military aircraft finishes. If you made it all the way through to the very end, we want to sincerely thank you. It genuinely means a great deal to everyone here. You're among our most dedicated viewers, and we truly value your support. We promise to keep putting in the effort to make our next video even better for you. If you liked this video, please hit the like button and think about subscribing. It helps us out more than you might realize. Thanks once again. All components are thoroughly tested. Every detail of the servo system, every signal transmitted from the remote control, and every movement of the steering and thrust mechanisms. Each command is checked to ensure it translates into precise, reliable motion. The SU35 inspired watercraft is now fully constructed and prepared for its first tests and launch. It sits ready to fulfill its creator's vision, poised to skim effortlessly across the river, just as once imagined. From the meticulously molded fiberglass cabin to the robust propulsion system, every component showcases the dedication and passion invested in its build. After countless hours of effort, craftsmanship, and persistence, this extraordinary project has reached completion. What started as nothing more than a bold idea has now taken shape as a stunning reality. This watercraft is far more than a machine. It is a physical expression of a dream raw materials transformed into a functional artistic creation through determination and creativity. Each part reflects a challenge conquered, a step forward, and a reminder that with enough commitment, even the most daring visions can be brought to life, flying across the water with the spirit of a fighter born from the clouds. It glides just above the river's surface with the grace of an aircraft in open sky, capturing the essence of high-speed flight while carving its path through the water. If this project sparked your interest, don't forget to subscribe. There are many more amazing creations coming soon.